Good afternoon, students. This is Mr. Osei Kwame. We have been presenting variation as our topic for core mathematics for SHS 2. We have previously dealt with the definition of a variation, and the types has also been spoken about. We have taken one of the type and also dealt with it in our second video, and that was a direct or linear variation. Let me recap some few things before I go to the next subtopic, which will be indirect or inverse variation. We learned that variation in mathematics involves two or more quantities, and they are related in such a way that the change in one quantity brings or results in the change in the value of another quantity. We found out that in variation we can have, as I said, direct or linear variation, or it can be indirect or inverse variation, which I'll be dealing with today, or the third type can be the joint variation. The last will be the partial variation. We have seen that variation is symbolized mathematically by this symbol, the symbol of variation. Don't forget that variation also is called proportion in some instances. Proportion. Now, we also know or learned previously that there should be a constant calculated always. We call it the constant of proportion or the constant of variation. This constant is a quantity that remains unchanged or cannot be altered throughout the problem solving. It is fixed, and therefore it is a constant. We normally represent it by the letter K in most of the books, but any other variable can be used. We saw that in direct variation, the increase in one quantity or the value of one quantity or variable results in the increase in the other quantity or quantities. We realize that the decrease in one quantity also results in the decrease in the other quantity. That was a direct or linear variation or proportion. An example or a general simple example is when there's an increase in the cost of petroleum products, then it affects the increase in the cost of transportation of goods, persons, or in services. We also saw that when there's a decrease, or we've seen that when there's a decrease in petroleum products, then there's a decrease in the prices of some goods. So direct variation was seen in those examples. Now, with that understanding, we move today to the second or the subtopic today, which is the indirect or inverse variation. The indirect or the inverse variation. When we talk of inverse variation or the indirect variation, it is when one quantity value increases, it results in the decrease of the other quantity in the relation or in the variation equation, and vice versa. What I mean is that, or when there is a decrease in the value of one quantity, it results in the increase in the value of the other quantity or quantities, as the case may be when we go to joint variation. Remember that most of the time for direct and indirect variation, we use two quantities. We saw, as I said, that indirect variation, the change is proportionate. The increase in one results in the increase of the other. The decrease in one results in the decrease of the other. But for indirect or inverse variation, the change is disproportionate. And what I mean is that when one quantity increases, the other quantity decreases. And when one quantity decreases, the other quantity increases. So the change is disproportionate. Disproportionate. Remember that in every case of variation, you will always have to calculate the constant of variation. Now, mathematically, inverse variation is written this way. Supposing a variable y varies inversely to x, then it is written as this. Y varies inversely or indirectly to x. In inverse variation, as one quantity increases, in this case as y increases, x will decrease, the other quantity decreases. And when y decreases, x increases. Remember that the concept of variation will be introduced, and we can now solve questions like we did under the direct variation. But let's see something. In real life situation, inverse variation happens a lot. Example, when a car or an automobile travels with much speed, it takes less time to cover a particular given distance. What I'm saying is that when the speed increases, the time the car used to cover the distance decreases. So if v is the speed is the term that the car uses to cover the distance, then we can say that V varies inversely as T. With the increase in speed, less time, there is a decrease in the time to cover the distance. On the other hand, given the same distance and all things being equal, when the speed is slower or you decrease the speed, then the time taken becomes more, or there's an increase in the time taken to cover that same distance. Another real life example is what we sometimes see in the season of some products in the market. Some example in the fruits. When there's more of that fruit in the system, the prices are less. The increase in the quantity of that product in the market will result in the product becoming more cheap. But when the season passes and the product becomes few, there's an increase in the price of the product. So the decrease in the quantity of products in the market results in the increase in the price of that product. And over there, we can also see inverse variation. Now, observe that in each of these cases, well, I said y mathematically varies inversely as x is written this way, and when I talk about the speed and the time taken by a car to cover a particular distance, we have not introduced k, which is a constant of proportion. I said the constant of proportion remains unaltered. It's a constant. It is fixed. From the previous studies, if you follow, you solve examples under direct variation. And you realize that you always have to calculate the constant of proportion or the constant of variation with the given values that you have for the other quantities. Now, let's note something quickly. When I introduce the k, I'll start with the first example I wrote. We have learned previously that when the k is introduced, then the variation symbol is changed to equal to. So here we have k on x. Or some books write it this way: y equals to k into bracket 1 on x. Some books also would like to write it this way: xy equal to k. Observe it. Now, when you are given inverse variation and you introduce the constant k, we realize that then before you proceed to solve any question, we will always have to find the k, or the constant of proportion. And the constant of proportion, when it's found, is fixed back into the relation or the equation before you can use it to solve problems. I want you also to note that in inverse variation or indirect variation, the product of the two variables is equal to the constant of variation, given that there are only two products for here, or two variables. And what we are saying is that the product of the two variables is equal to the constant. Now, how do we use inverse variation to solve problems which obviously falls under inverse variation? Here are the steps I would like you to take, which will be applying when I start solving questions. First, write the correct equation. Remember that if you take a direct variation equation to solve an inverse variation equation, that equation is wrong. It can't solve the inverse. So, always make sure that your equation is correct. In other words, it is an inverse variation equation, which I've shown you. One of the ways you can understand or remember is that for inverse variation, provided that the ratio of change is constant or the constant of variation is given, then one is a reciprocal of the other, provided that k is given. One is a reciprocal of the other. So 1 write the correct equation, and in this one use the variables that are relevant or given. If you are given symbols, use them. If you are giving your own symbol or using your own symbol, note that and use it. Step 2. Make sure that the information given to you is used to calculate the constant of proportion or the constant of variation. You will find out that we give you some information. There are those that are used to find the constant of variation. From direct variation, I know you saw that. Step 3. Now, fix or substitute in place of k the value of k into the equation you started from step 1 and 2. Then the last step, you can now use the equation which now have the value of the constant to look for an unknown variable or quantity. We will consider some few examples before our time is up. These are very simple ones. And I'll continue from the first one I started so that it's more simple for us or more meaningful. Example 1. If y varies inversely, as x, If y varies inversely as x, given that x equal 7, y equal 3. Find y if x equal 9. If y varies inversely as x, given that x equals 7, y equals 3. Full stop. Find y if x equals 9. In our solution, we take the steps. Step 1, we look at the type of variation, as I said, and make sure we write the correct equation. So, it will be y varies inversely as x. Y varies inversely as x. Here is the correct equation. The next step is to introduce our constant and find it. So it will be y equal to, yes, you got it right, k on x. Y equal to k on x. I showed you how other books can write them. Let's keep this. Y equal k on x. Y equal k on x. We have gotten the step 1 correct because it is inverse related. Y and x are inversely related. We've introduced our k. So we are into the step 2. Into the step 2, we have to find our constant k. The constant of proportion or the constant of variation. To find k, step 3 tells us that go back and look into the question given to you and pick out the informations you need. Over here, you realize that from direct variation, if you follow through, the first values of the two quantities are what is used to find k. If it was in the table, you'll pick one value of the x and its corresponding value of the y. Now, here we have been given x as 7 and y as 3. So, I'll substitute wherever I see x 7 and wherever I see y 3. So we have 3 equal k on 7. And simply cross multiplication will show you that we can multiply this 7 to 3. And we get 21 as a constant. So after writing the equation correctly, the second step is look for k. We've solved for k. The third step is to fix k back into the equation where we saw k, where we began. And after this, the relation or the equation is now complete, or can be used to solve questions in step 4. So now the equation becomes y equal to 21 over, or 21 on x. By this, we have now gotten the relation between y and x. It is now complete. Remember, if you've not solved for the constant of variation, the relation is not complete. Students, I believe this simple example has given you an understanding to some level of inverse variation. So, let's complete it. Now we have to find y if x equals to 9. Now that we have y equals to 21 over x, or 21 on x, going to the step 4, we are to use this relation to solve for y. So what we do is that wherever we see x, we substitute 9. So this implies we have y equals to 21 on 9. Because x equal to 9. When we simplify further, we get 2 whole number, 3 let me break it down before so that it's easy. 3 goes here 7, 3 goes here 3. So now 2 whole number, one on 3. Two whole number, 1 on 3. That is y. That is y. A very simple example for us to grasp. Let's pick another example. Guess you finished copying, so I can now clean it. Example 2. If R varies inversely Remember, I said it's the same as indirect, or they might say varies disproportionately. R varies inversely as the cube of x comma and r equal 5 and s equal 3. Full stop. Find r when s equal 2. If r varies inversely as the cube of s and r equal 5 when s equal 3. Full stop. Find r when s equal 2. Okay, so in our solution, step 1 is to write the correct equation. So for the correct equation, we have r is inversely proportional to s, 1 over s. R equal to k over s. We've gotten our equation correct.